In this section, we'll look at context windows in large language models and why they matter for AI job seekers. A context window is the amount of text a model can consider at one time, which affects memory, prompting, and performance. Understanding token limits, trade-offs, and the system design around them helps you speak more confidently about real-world LLM applications in interviews and on the job. A context window is the total token budget a language model can use at one time while generating an answer. That budget has to cover three things: input tokens like your prompt, documents, and chat history, output tokens, which are the model's response, and, in some models, reasoning tokens used internally. The key idea is that all three draw from the same limited pool, so using more of one leaves less room for the others. When we talk about context windows, we're really talking about tokens, not words. A useful rule of thumb is that one token is about 4 characters, or roughly 3/4 of a word in English. And those tokens get used by everything in the prompt, not just your question, but PDFs, code, chat history, tool outputs, and the model's own answers. So in practice, many different sources are all competing for the same limited space. By 2024 and 2025, long context windows have really gone mainstream. We're seeing models handle around 1,000 tokens routinely, with some reaching 400 or 200 in smaller configurations. The key point isn't just that bigger context exists. It's knowing when it actually helps. More context can improve continuity and retrieval, but it also adds cost, latency, and sometimes noise. So the real skill is using long context deliberately, not automatically. A big context window can feel like the answer. If the whole prompt fits, problem solved. But that's really just the visible tip of the iceberg. Underneath, the same architectural issues still matter. Latency goes up, costs rise, relevant details can get diluted, and memory pressure builds. So even with large windows, you still need thoughtful system design to decide what the model sees, when, and why. This slide is about the token budget triangle. In practice, every design choice is a trade-off. If you give the model more context, you usually get richer, better grounded answers, but latency and cost go up. If you cut tokens, responses get faster and cheaper, but you may lose key evidence. And at scale, KV cache growth can become a real memory bottleneck. The goal isn't maximizing one side, it's balancing all three. This slide shows how information moves through a model's context window. The user input goes in first. The model applies attention across everything in that window, and the generated output comes out of the same overall token budget. The key trade-off is simple. Every token you use for instructions, examples, or prior conversation leaves fewer tokens available for the response. And because output limits are fixed, you need to budget that space deliberately. Overflow should be treated as a production failure, not an edge case. With OpenAI, the practical fix is to shorten prompts, chunk long text, or summarize inputs before sending. Anthropic recommends counting tokens ahead of time, and newer models will return a validation error if you exceed the limit. With Google, remember that images and audio are tokenized too, so non-text inputs also consume context window capacity. This is really a core architecture decision. Do we just stuff more context into the model, or do we design the system around the limits? In practice, strong teams don't rely on bigger windows alone. They use retrieval to pull in what matters, summarization to reduce noise, and staged compression to preserve key information across steps. That's usually the difference between a system that scales cleanly and one that becomes expensive and unreliable. Here are the core design strategies for working within context limits. With RAG, we retrieve only the most relevant chunks at query time instead of loading everything. Summarization helps compress long content before it goes into the prompt. Chunking breaks large inputs into smaller stages for processing. and memory management keeps only the conversation state that's actually relevant to the task. One important thing to remember with reasoning models is that the hidden reasoning tokens are not visible in the API response. You won't see them directly, but they're still billed as output, so they use budget and add to cost. That means you need to plan for them when setting token limits. OpenAI's guidance is to reserve at least 25,000 tokens total for both reasoning and the final output. Here's where candidates often get tripped up. Context limits aren't just about the headline number. With OpenAI, reasoning tokens may be invisible, but they're still billed. So you need to reserve room, especially for O-series models. Anthropic's thinking blocks don't carry forward, and overflow throws a validation error instead of truncating silently. Google also counts multimodal inputs, so images and audio reduce your text budget. Bottom line, provider behavior shapes usable context. Under the hood, the key challenge is the KV cache. As each new token is generated, the model stores past key and value states so self-attention can reuse them instead of recomputing everything. That makes generation efficient, but the cache grows linearly with sequence length, so memory becomes a major bottleneck for long contexts. At scale, this really matters, which is why VLLM's paged attention can boost throughput by 2 to 4 times through smarter paged memory management. When working with LLMs, it helps to know your role and how deep you need to go. For AI product teams, context limits shape user experience, reliability, and cost. Applied AI engineers need to understand token counting, chunking, RAG, summarization, and evaluation. And at the systems layer, the key concepts are things like KV cache, continuous batching, paged attention, and other techniques for memory-efficient serving. Here are 3 interview questions that come up a lot. First, why not send the full corpus every time? Because it increases token cost and latency, can hit output limits, and often lowers answer quality by adding irrelevant context. Second, for long chat histories, I'd summarize earlier turns, keep only task-relevant state, and use retrieval instead of raw memory. And when describing a system under context pressure, I'd explain chunking, compression, caching, and the trade-offs I measured. A strong portfolio project doesn't just show that the system works. It shows how you evaluated it. Measure token counts and cost per request, compare latency across providers, and look at answer quality as context grows. Also, document failure cases, especially when context overflows. If you can explain why you chose RAG in one design and full context in another, that shows real product judgment, not just familiarity with the API. Here are 3 strong portfolio project ideas. First, a document QA comparison that benchmarks naive, full context prompting, RAG, and summarization on answer quality, cost, and latency. Second, a token-aware chat assistant that monitors token usage, truncation risk, and response speed across providers in real time. And third, an agent memory workflow that can decide mid-task whether to keep full conversation history or switch to a compressed memory state. Here's the decision framework in practice. First, apply the method. Chunk the material, use retrieval when needed, then summarize or compress. Next, choose the strategy that best fits the task. If the budget allows, a full context prompt can work well. Then check context fit. Does everything you want to include actually fit within the model's limits? The key instinct is to give the model what it truly needs right now, not just everything you can stuff in. Here's the hiring signal. A junior candidate says, Model X supports 1 million tokens, basically repeating the spec sheet. A senior candidate does something different. They design around the real constraints, measure the trade-offs, and build systems with cost and latency in mind. The point isn't to memorize the biggest number on the model card. It's to show that you can make good design decisions because of the constraint, not despite it. Here are the key takeaways. Tokens are the core unit behind everything, and input, output, reasoning, and multimodal content all draw from the same budget. Bigger context windows help, but they don't remove the need for good system design. Cost, latency, and relevance still matter, which is why skills like RAG, chunking, and summarization remain essential. What really stands out in hiring is measuring results and showing real metrics in your portfolio work.